Started now. So thanks for joining. This is Dan from Proplanner, and today we're going to talk about Proplanner's MES solution for helping to communicate to operators what work needs to happen, what parts and tools are required, and then really what's happened on the shop floor, how you're overall kind of executing and coordinating the work. So a little bit of housekeeping first. The plan is we'll spend about 45 minutes or so just going through the software, walking through some different use cases and different features. And then we'll spend the rest of the time working through any questions that have come up during the webinar today. So you can go ahead and submit any questions that you have through the chat feature. I'll be able to see that, and we'll collect those until we get to the end of the conversation. So let's go ahead and start. So overall, Proplanner is all about assembly process collaboration. And I'm going to use the word assembly, and most of our solutions are really targeted towards assembly, but these concepts certainly apply to other areas within manufacturing facilities. But this concept related to collaboration, it really extends beyond MES and the execution piece on the shop floor and communicating to the operators. And as much as anything, it's about preparing for what is going to happen on the floor and ensuring that all of the necessary stakeholders and systems are aligned on what the plan is and everything remains synchronized. And that's really what we'll be taking a look at today, is how that occurs. Okay. Problem with the slideshow hanging up. We'll just go this direction. So, of course, we're going to be talking about MES, and we're going to hit some of the big topics that you would see: communicating the work instructions to the operators, recording what has happened, who interacted with what. We'll take a look at serializing information to the unit. Think of that as building the as-built BOM. We'll also take a look at managing issues and defects, so non-standard things that can happen on the shop floor. What we would consider to be kind of standard features that you would expect within a MES system. But we do want to take a step back first and talk about, so why Proplanner? What's actually different about this compared to other standard MES systems? So first, some grounding discussions. Which types of companies or product mix would typically be used by Proplanner customers? The typical users of our MES system, and this is not all encompassing by any means, but it's manufacturers of discrete products in a high mix, low volume environment. And when I say low volume, right, that could be that you have takt times even less than a minute. But probably the more important point on that is the high mix side of things, where you have a large degree of product complexity, and managing the data associated with that product complexity is a paramount aspect of your process planning or manufacturing process management system. The other group that we would commonly see would be companies that have really a strong quality requirement on their shop floor, driven by either regulatory or supply chain regulation and compliance requirements. So think of it, if you need complete traceability and you need to be able to go back potentially decades, right, to look at what exactly happened to your products as you support the full life cycle, cradle to grave, of a manufactured component. That really represents the types of companies that would typically be utilizing Proplanner systems. Okay. And when we dig further into this of why Proplanner, the thing that most companies will tell us is that the heavy focus that Proplanner has placed on process design, the ability to create different scenarios, different possible process plans, really collaborating between manufacturing, industrial, and logistics engineering, that helps you to determine and ensure that you have a plan for the right tools, parts, the work instructions, the data into your ERP system, right? All of that information, ensuring that that has been created approved and released in advance of when the different systems and people need to know that data. It's one of the big reasons why people would elect to go with Proplanner. We carry that information, as we're focused today, from the process planning environment into the execution environment, which again will be the focus. So if we get out of PowerPoint here and focus on the actual software, let's take a look at the agenda for what we're going to cover today, and then I'll also point out what we're not planning on covering. So today, it's really going to be focused on how you get the data from the planning environment to the shop floor system, the typical operator experience on the shop floor. We'll look at data collection capabilities of the system, and then we'll also look at handling some non-standard events, notably repair procedures and non-conformances. Future demonstrations will focus more on some of what I would consider to be the tangential pieces, still critical, but really tangential to the core. And that would be, how CAD data is able to integrate into the operator's instructions, getting the parts delivered to the station via a Kanban or kitting system, integration with torque tools and other shop floor devices, wearables for communicating using things like Google Glass, communicating to the operators, and-on and dashboard capabilities, and then scheduling and inventory planning capabilities within Proplanner. Okay, so first, let's go ahead and take a look at what the operator will see. So just the basics. I want to show you where we're going to end up first. This is the web-based application that is used to communicate to the operator the work instructions and where they're actually interacting via a tablet or a PC on the shop floor with the production unit in front of them. And so just real briefly, as an operator, what I'll do is I'll select the unit that I'm working on, typically scanning a traveler, and then I will go into the instruction, and from here, I will take it away with actually completing the process on the unit and documenting the information. So this is where our data is going to end up. Now let's go ahead and work backwards. How did we get here? So this application that I just pulled up, a WinForms application called Assembly Planner, is used to create the process plans. It's used to create the work instruction documents, time studies, line balancing, many of the industrial engineering functions. You also have establishing plan for every part data for how you are going to, for documenting, how you will actually get the parts delivered to the station. So this is where really the engineering teams and the work instruction authors would spend the vast majority of their time. Here, what I'm going to do is I'm going to enter the system and I'm going to process the change for whatever type of change, right? It could be that I'm planning for a brand new assembly line. It could be that I'm processing a very mundane ECO that Proplanner has received from your PLM or PDM system. It's, I'm swapping a bolt from one part number to another, whatever it may be. But what I will do is I will come into my process routing and I'll make the updates. So here I'm in the routing for assembly line 1, and I have my series of stations that we call operations. I can drill into my operations and then I can see the activity list, what the operator will need to do at the station. Within each activity, I then have the, most notably the list of tools, parts, and then possibly the detailed steps that are needed. And to connect a dot here, let me go ahead and get something pulled up for you. So we looked on the shop floor at this image. You see that image is available here. Of course, we have work instruction authoring tools like image editors. You'll notice that we have the video player here that can be used to communicate the video to the shop floor, which we'll look at in a minute. It can also be used as part of the time study. This demonstration today is really not intended to be an all-encompassing review of the work instruction authoring or the industrial engineering capabilities, but we'll briefly touch on a couple of points. Okay, so first, You may have attended or seen the webinar that my colleague Jared provided last week covering the consumption workbench. Or what I'd like to do, first of all, is I'd like to go through just a real brief example of how I can update the parts list associated with the process. This is all about preparing the data that'll go to the shop floor. So one thing that I can do is I can take, I have here, I can have a component that has come in, a changed parent assembly. Help if I could read. There we go. So I have an engine assembly. This is the engine chassis system as a part of some change that has come into Proplanner. See that I have that here. The system has then determined that I see that parent assembly within these operations. Then what I'm going to do here is I'm going to load the workbench. And here I have the same prep tray operation with the parts list that you can see in the background. This is my active parts list. And here I have a list of the components in that assembly that have been added that are not yet being consumed by my work instructions or by my routing. Similarly, I have deletes and changes and pending updates. But all I need to do, if I want to say that I want this operator to install this component, is I can drag and drop the part in. Go ahead and press close, and now you'll actually see that that part is listed here. Which brings up then an important point. This particular component may only be installed if you have a certain configuration of unit being built on the line, meaning that the order that the operator is signing on to, it will have something that describes the configuration of the product. It's this particular finished goods SKU, or it's this model ID with variant or configuration information applied to it. And what we can do within Proplanner is we can say, okay, this particular process and the parts being installed by that process, they can have that configuration or effectivity information applied to them. We'll go ahead and do that now. And I'd like you to focus in on the model and option fields here. And what I'm going to do is I'm going to update the data. And what the system will do is it's going to evaluate based upon the bill of material data within Proplanner. And it's going to determine that, hey, this 316277 part number has come into the system. It is effective starting on today's date until my end date. And it is going to be effective if you're building this particular model year 2019 good that has this option code assigned to it. Now from here, I'm on my consumption list. I can also do things like, hey, I want to trigger the operator. I want them to scan the part ID on the floor, or I want them to scan the serial number. We also support being able to scan or input manufacturing or supplier information like the lots or the manufacturing date information. Okay. If I take a look at the work step tab and I switched activities, I can also see that via work steps, Proplanner has the capability to drive different types of what we call work step tests. And these are tests that require, or checklists, if you will. These are planned standard work that allows you to input dimensional information at a range or at a certain target, or you can do pass fails and yes nos. Additionally, you have the capability to specify if the result that the operator inputs, is it required that it matches the specification that the engineer has input here? Effectively, we can say, is this a go, no-go criteria in order to sign off that activity? And we'll take a look at that in more details on the shop floor. Okay, last but not least, the tool data. So I have the ability to associate resources or tools to the process, where I select the tools from the library that is established for the plant within this planning environment. So I can say that I want the operator to install or use this 5/16 inch nut driver, and I can go ahead and drop it in. Okay, So I'm updating my work instructions, updating the process plan and the routing, the bill of sequence, really whatever terminology you use here. It's all one and the same within Proplanner. Now, some other things that I can do inside of here. I have the ability, utilizing our line balancing module, I can take the same activity list that I'm interacting with. You might notice there's some of the descriptions are the same with what we were just looking at. And I can take these activities, I can actually then drag and drop this work to other stations. Assigning the work, the system will perform a constraint validation check. And here I can see I've got a lot of greens and a lot of reds. Those mean good and bad, right? Are you violating conditions that you've said should or should not be met? I'll go ahead and make the move anyway, and then the system is going to update my mixed model line balance charts with the appropriate average or weighted times based upon my model mix. Okay. One final thing that I want to bring up before we actually release new work instructions to the shop floor is related to effectivity management. And we took a brief look at that when we talked about the model option mapping of the components to the activity when we use the auto model option mapper. But what I also wanted to point out, and as an extension of line balancing, right, that line balance, it's all about planning in advance. I could be introducing a new station, or as I did in that quick example, I moved work from one station to another. But I can plan for that work to occur at some time in the future. For example, maybe October 1st, I want to introduce a new process or a process change. And so, of course, if you're familiar with routing data or bill of material data, right, we use the same concepts where we have effectivity dates. And what I can do here is I can say, well, I want my process to be timed in, this station in this case, to be timed in starting October 1st. Similarly, I have the ability to say this particular process, I want to time in beginning on this particular unit serial number, giving you very granular control over when process changes will go into effect. Okay, now I'm going to actually reset my demonstration data set here prior to going and publishing this data out. So what I will do here to actually release this data, and I want to point out, I'm skipping a whole number of steps, assuming we're not using any workflows, we're not connected to the PLM systems or anything like that. So I have kind of global admin privileges here. And yeah, I skipped a large number of steps to get to the release process. And what I can do is I can either directly take that line balancing scenario that I was working in, where I dragged and dropped the task with the charts, or I can take my routing directly, and I can actually make an update here. And so I'm saying, well, I want to publish new instructions from this line for this particular product. And I might say, well, I want the operator on the floor, I want them to, I want to let them know and force them to acknowledge that some change has been implemented. And so I could say, well, I have some engineering change document number, and I updated tooling. Here, what I'm going to do is I'm going to say I added, I think it was the 5/16 inch driver. We're going to go ahead and add that. Now what I'm going to do is I'm going to publish this data to the shop floor. These changes may be active on the very next unit that the operator is going to work on, or as we just discussed, given the effectivity controls, these changes may go into effect at some point in the future. It could be next month, next year, doesn't matter. Okay, so at that point, the engineer's work is complete, given that we've stripped away all of the approval requirements and all of those things for this demonstration. And now what we're going to do is we're actually going to go back into the work instruction. So right now, I'm in preview mode, and I have work instruction revision 39 pulled up. We're going to go ahead and go back to my build list. So this time what I'm going to do is I'm going to actually do a sign on. And here you can see under work instruction revision 40, I have the change request that I just created. The operator now needs to acknowledge that before they can actually get into the work. So what I will do is I will go ahead and select that, acknowledging and creating that electronic record. And I'm now going to move into the work. You can see it notified me that I'm in sign-on mode. Okay, let's take a couple of minutes and talk about what we're looking at here. So in the header, I have descriptions of where I'm working and what I'm working on. So I'm at station L1A, filling operator role, operator role number 1. I'm working on activity 11, which is called prep the tray. And this is an activity ID analogous to a part number. It's not activity 11 in the sequence. It's the first activity, but with activity ID 11. And I'm working on a product that is a T4F model year 2019. And I'm working on the unique serial number VIN 001. I have the list of images in my gallery here. I may have a video associated with this particular process. Down at the bottom, you'll notice that I have time tracking that's occurring, where I have the standard time from the time study, and I have the current elapsed time from this session. I'm going to kind of work counterclockwise through and finish with the parts. Have the information around who is installed, and I'm signed onto the unit using a fictitious operator name called regular operator. We can see that I am in the mode where I'm editing data. So everything that I'm doing is being recorded against this particular VIN number with the appropriate timestamps through the logs. And I have editing enabled, so I'm able to modify the data at this point. You may have a list of standard documents that you want to provide the operator access to, or links on your intranet or out into the internet that they should be able to get to. And so here I have the ability to create a customized list of different supporting documents. I can also see the change history log. This is showing the activity history records along with the work instruction history records, with the one that I've signed off just a couple of minutes ago, shown at the bottom. I also have the ability here to generate change requests. And so this is a way for the operators on the floor to submit a request with the context of the activity that they're currently working on. And what I can do is I can then say, well, I need to, I'm just making this up as I go here, but I can go ahead and create this. And that then triggers an email notification to the engineers that are tied to the particular change notification list. Okay, now I'll go ahead and close this up. Okay, and then we'll go ahead and keep looking at what the operator is able to do. We'll come back to these buttons at the bottom. Here I have the list of work steps. I only have one that's listed here. This is just telling me, hey, first thing to do is review your assembly drawing. And it happens to have a key icon on it saying, hey, you need to go to the inspection task. Okay, now we'll spend a couple more minutes here, and I want to point out something first. Right now we're in a mode, one view style of the shop floor viewer, where I'm looking at all the parts that are needed for this process. If I had multiple work steps, I would see them all here. This is kind of my multi-work step view, where I see everything that I'm doing for this prep tray process in one shot. Through simple configuration parameters that are already ready to go, I can flip the view so that I'm seeing one work step per page, which is more popular at the manufacturers that use Proplanner with quite a bit longer cycle times. We find that that view style to be used. So we have control over the content that's displayed in terms of what fields will show up, the scope of the work that will be displayed to the operator. We can also control which tabs are being displayed. So I can see the work groups. I can see the parts that need to be installed. If I've associated an image, I can pull that image up in a full screen mode of that particular component. And if I have a tool list, I can see that here. Okay. Now, probably the most important point for most manufacturers is that I have my parts list. What this parts list is doing is it's communicating to me when I see these red boxes that I have data about this part that I need to input before I can move forward. So if I try to hit the green arrow to move forward, it's going to tell me, hey, wait a second. I cannot sign off this activity because I have not collected a part number nor a serial number for that same component. So we need to go ahead and do that. And we'll do a couple of things here just so you can see some of the data validation issues. Let's say the operator scans a different part. Well, one of the things we want to do here by having the operator scan the part number is we want to confirm that the serial number that they're scanning is from the part number that we're actually looking at, right? That we're intending. And so one of the ways to do that is to have them scan the part number, and then hopefully that serial number label will be quite close in proximity, and the operator will then scan the correct one. Here, what we can see, maybe they scanned their Mountain Dew bottle or whatever that's at the station. It determined that, hey, we don't have a match, it's going to reject. I can go ahead and fire off my update. And then we're going to notice we have another issue. Wait a second, why is it not letting me move forward? Well, the system is telling me, and it's recording all of these messages that are being provided to the operator. What it told me was that, well, this particular serial number of this component, that has a blacklist issue. In this case, it has a non-conformance. Meaning this particular instance of this part, this physical component, was not properly moved to the red tag cart or the holding cage or whatever your company uses, where you would put components which should not be installed on the shop floor. So in this case, Proplanner is acting as a rubber meets the road system, if you will, where we're saying that particular serialized component is not in a released status to be used. Therefore, we're going to reject the operator from signing off this activity. Okay, we'll take a little bit deeper look at the NCRs later. Oops, looks like I picked another one that's still bad. Let's go ahead and move forward with this one. There we go. All right, so now I'm on my next activity. So the operator in this case, they manually advanced, I did, by hitting the green button. We also have the ability to automatically advance based upon the elapsed timer, incorporating checks that they've entered all of the correct data. Here I have another activity, just moving forward. In this case, I have two images. You'll notice that as I toggle back and forth between the images, it's highlighting the work step group, which is really the ability to say this collection of work steps, the standardized work that you want the operator to complete, is associated with this particular group. It's a way to draw the operator's attention. Here, again, I have another parts list, and now I have multiple work steps that need to be populated. What I will do is I'm going to go ahead and enter some data. I'm not going to go through all the different failures as you've seen kind of what those validation failures look like. But I can go ahead and enter some data. We do have a lot of deviation related capabilities. In fact, there's a whole deviation module within the planning and the shop floor system. I'm not intending to get into that today. But what I'm doing here is I'm actually noting and I'm requiring in my standard work that the operator input a deviation ID. Similarly, I can have optional deviation IDs that the operator would need to associate to the unit. So it's just saying, hey, did that deviation, that process change or part change, did it actually apply to this thing that's being built? Go ahead and move forward. Okay, so probably getting the idea at this point. I do the work, input my data, hit my green arrow, and move forward. So the system is tracking all of this as we move forward. And what I just did was I navigated to what we call the process tree. And this is either a line level or a plant level view of what status this unit has through the process. So let's break that down in a little bit more detail. Right now I can see I have all the operations across the line. I'm signed in as a regular operator, so I don't have the ability to see what else happened on other lines. But I'm currently working on the very first station, and you'll notice that there's 4 different branches here tied to operation 1. That means that I have 3 colleagues that are also working on operation number 1, fulfilling operator roles 2, 3, and 4. Right? There's 4 people at the station. I'm the only one that started my work. And when I expand this, you can see that I'm green, good to go on the first two activities. But then this sub-transmission that I'm highlighting right now, that's the activity that I just left. I have signed on, but I have not signed off, or I have not noted that those parts have been installed. So it's picking up that I have 5 missing components. I can compare that to the Components tab that I have selected here. And it's showing me that I have 4 different part numbers that have already been installed, one of which contains a serial number I've installed here. Okay, so the operators have the ability to get at this data, and based upon their role privileges that we'll talk about more in a minute, they have the ability to perform different types of functions from this screen. So let's talk about what some of these other tabs represent. Okay. So first, on the Components tab, certain operators are able, outside of the work instructions, they're able to actually delete the components or remove the component from the unit. Okay, so the idea here is, well, you may not trust that a regularly trained operator is able to execute some non-standard repair process, which is effectively what this would be, or a rework operation. And you definitely would not want them doing that from the process tree where they have no instructions being displayed to them. But maybe you have more advanced operators and you are allowing them to do that work. So we use role privileges to control who can do that. Similarly, certain operators have the ability to generate what we call test failures. Test failures are one of the non-standard work elements that we can associate to a unit that's established natively on the shop floor. And so I can file test failures along with some of the other attributes that we have listed here by selecting this folder icon, and we call these exceptions. So here, what I can do is I can say, I want to file a test failure. We already know the context of the unit that we're working on, and we're going to file it from station L1A for operator position 1. I can go ahead and press create. Now, from here, I have maybe more privileges than you would typically afford to a regular operator. Generally, with a regular operator, you would have the ability to say, hey, I've had a problem. You maybe associate a failure code, but that really then serves as a placeholder for some other person to go and actually complete the work. So I just went ahead and saved it. And you can see in this case, now we have our unique ID on this associated test failure. This is an active test failure that needs to be resolved. And we will then document, as we move through the resolution of this test failure, the number of actions and retests that have been performed against this. So now imagine that I've signed in as an operator with repair privileges. From here, what I'm able to do is I'm able to now associate different actions, where what we're doing is we're recording what was required to complete the installation or complete the remediation of whatever issue was determined. Could be that the repair operator looks at this and they say, I don't actually think there's anything wrong. And so they say there's no fault found. They can add their comment if they would like to what they actually observed, and then they can go ahead and press save. Now from here, I've started to edit things, and you'll notice that the ability to cancel went away. There was a little red button at the bottom. I can no longer blow this thing away because we have now recorded data against them. So my options at this point are to keep adding actions, add a test because maybe I executed a retest, and then I can promote this to a review state where maybe somebody in QA needs to review it to sign off. And then finally, I could promote it, given I have super privileges here, to a completed status to actually close it out. But what I'm actually going to do now is we're going to execute a process where we're going to replace this part that was serialized. We're going to jump back in here, and we're going to go to add action. And this time what we'll do is we're going to do a part replacement. Go and replace my part. Again, we'll do the simulated Mountain Dew bottle scan. The system's going to say, it says, okay, I'll work on that error message. It should say that part's not installed on the unit. Go ahead and actually enter a real part number that's currently installed on the unit. And then what the system is going to do is it's going to say, okay, you're filing an action for replacing the part. It determines that that was a serialized part. Okay, well, if that's a serialized part, what serial number did you replace it with? I'm going to go ahead and replace it with new part number, or excuse me, new serial number. And I want to focus your attention on this box all the way over here that says File and NCR. The concept here is that if I am replacing this component, this serialized component, due to a test failure, at the discretion of the person performing this action, they may realize that that thing should have a non-conformance filed against it, this prior serial number. And so I can go ahead and initiate that non-conformance during the creation of the test failure. Go ahead and press save. It's going to validate that this serial number that I've added is good to go. And it's also going to create the initial non-conformance. Now I'm back at my test failure overview screen where I can see the series of actions that have been performed. I may say that, well, I've replaced the part. Now I want to actually perform another test. And this time I want to say, well, I had a passing test. Now I can go ahead and press save. Because I have a passing test result, now my root cause box is able to be populated. And I'm going to say that this particular test failure was a cause, or it is a supplier related root cause. At least that's what I think. Now this test failure has been promoted to the review stage. I may or may not, with my current role, be able to do anything with this. Right? Likely that will go to another person. In my current role, what I am able to do in this case, though, I'm able to either revert back to the active state, meaning I want to do more, I want to add additional tests, additional actions, or I can promote it to the completed status to close this out. Now this test failure will not block the user from proceeding with the unit. So basically, it's not going to prevent this unit from being released, either from the activity, from the stations, or from the individual line. Okay. Now, taking a look at some of the other items that can be filed. I'd mentioned that we have deviations. I can file deviations also from this process tree against the particular unit. Deviations really will be a separate webinar. I have the ability to create roadblocks. Roadblocks are, they can be of different types. In effect, this is a less robust way of tracking defects on the unit, where the test failure was some significant test that was planned, there was a problem. The squawk is a form of a roadblock that allows me to specify that I had a scratched part, I had a bent part, I needed to perform a deburring operation, or I needed to reconnect something, right? Something that I can easily fix. There's no test associated with it, and that's that. So I can file the squawk in that manner. Same conversation as the test failure. My current operator may or may not be able to resolve this. It may or may not be their responsibility to resolve it. And then that squawk or roadblock can then flow through the same review and approval or completion process that the test failure went through. Finally, let's talk about activity skips. So we have the ability to say, based upon the privileges of the user, that for some reason, they don't have the tool available, the tool is broken, or they've hit some problem. There's no issue with the unit, but they can't complete this activity. And based upon their role privileges, they may be able to file an activity skip as a placeholder that we need to go back to that activity and then jump to the next activity. Similarly, we have the ability to file what we call part skips. And here what I'm going to do, I'm actually going to remove that serialized component, and then I'm going to file a skip against this serialized component. Go ahead and say yes. So now I have work that needs to be completed installing the part. You say I have one missing component there. That's going to be filed as red. But then again, I know I'm harping on this, but back to my role privileges, depending on if I'm able to, I may be able to advance through the build process even though there's a missing component. Proplanner is used at facilities that really span a wide range, all the way from facilities that say you shall not move a unit forward 1 iota. You may not even, you cannot turn the next wrench on the unit if there is anything wrong, any missing parts, any defects. You have to follow the sequence that's been laid out in the process plan. Proplanner is also used at facilities that are on the exact opposite of that, where they will jump stations, sometimes even jump lines. They'll do work on the second line in a series of lines before the first line has been finished. They'll pick and choose which activities they want to use on, really at the discretion of the supervisors and the operators. All of that is controlled through the role privilege system that we'll take a look at as we start to wrap this thing up for today's session. I do want to go into the NCR list so we can take a look at the component that we just filed against the NCR. So here I can see I have filed an NCR this morning against serial number DM1237. From here, it's really sitting in a status of do not use on the floor, but it has not been sent officially out to the NCR disposition handling system. So I have the ability, actually, at this point, I could say, well, a privileged user could come in and say, I'm going to exclude this thing. I reviewed it on the floor. It's actually good to go. The operator was being overly cautious. That's fine. Also have the ability to cancel out the NCR. Or if I would like, I can create or add new components to this NCR. And I can go ahead and save it. There we go. And if I jump over to my NCR parts list, here I can see actually the global list of all of the components that have had NCRs filed against them. I can search by part number or by item serial number, really any of the attributes that you see here. I can also go in and then I can take a look at what has happened associated to that particular serial number against that particular NCR. From here, I may choose to also exclude that and say it's good to be used on the floor. I can initiate NCRs directly from this NCR list. So there are people that would use Proplanner if they're in like a supply management function. They would never go into the actual work instructions, but they can use Proplanner as the system that initiates that NCR. I can export the NCR list out to Excel if I have some need to, for example, send this to a supplier. I can get at that data quite quickly. But when I am at the point where I am ready to commit to this NCR, I then have the ability to actually promote this thing and lock it from editing within Proplanner, but move this data out. And at that point, what would happen is it would actually open up a separate screen inside of your primary NCR disposition handling system where you enter additional data, and you can see it's in this export processing mode. It's basically being taken from Proplanner, and then Proplanner is in a view-only mode of that NCR until the disposition status of the individual components has been sent back to Proplanner. Okay. All right, so a couple of things as we wrap up the session today. First, we'll go ahead and take a look at the role privileges, which I've talked about numerous times already. And I cannot stress enough the importance of role privileges, because the role privileges really control the business process rules that need to be observed on a per role basis. That controls things such as, do you allow the operator to do work out of sequence? Do you allow them to edit previously completed data? You can do things like, do you allow the operator to sign off at operations or stations, but they cannot sign off at stations that are missing parts or have open issues? You can imagine that certain operators may have elevated privileges and they're able to violate certain things as a part of the build process, right? As we're establishing this as-built data set as the unit is progressing through the line, It could be that you want the operator to make a judgment call because they have elevated privileges to say, we're going to go ahead and move forward even though we're missing a part. Now, Proplanner knows we're missing the part, and Proplanner also has the ability to say, well, we have special stations where even though that operator is able to sign off at regular stations with missing components, they shall not sign off at these special stations, end-of-line stations, repair or hospital stations that have missing components. So you have ways of controlling which of these different roles within the systems, maybe all, maybe none, maybe some of the roles, are able to perform these certain functions. Right? And so this concept keeps going. We have many dozens of different role privileges. We are very regularly expanding this list as people present us with new operational ideas or ways of navigating within the system that we hadn't dreamt of. And we can pretty easily add these into the system and make them configurable for all clients to leverage. Okay, so let's go ahead and next take a look at some reporting capabilities. First, what we'll do is we'll take a look at reports that can be generated to show what components have been generated on the unit. So I'm going to go ahead and pull up the list of components that have been installed associated with VIN number 001. Okay. You'll notice it is actually flagging where I have a quantity 0. In effect, this is showing me the list of parts that need to be installed on the unit that have not been installed. So we know these need to be installed, but they're not there yet. So it's able to flag those for us. Right now, it's breaking things down by operator, by station. If I want to, I can turn that off, that grouping capability. Now I can see the flat list. If I want to dump it out to Excel, go for it. Similarly, with this Proplanner system, I have the ability to say, well, instead of looking at the data through the lens of a particular unit, I could say, well, I want to look at my plan, and I want to see all of the places where this particular part is being installed. So I can see the different activities where I find this particular part, and similarly, I can export this to Excel. I'm going to skip down to the custom data report. And this is more of a raw export that's leading to an interesting discussion. Here, what I'm able to do is I'm able to see the data that's being collected in the background. And here I'm looking at what we call the unit item summary for VIN number 001. This is showing me lots of important information. Notably, this part number was installed with this serial number at this station by this operator at this point in time. We are collecting lots of logs, lots of information about the as-built status of the unit. As a part is added and then removed, serial numbers are swapped out, who did what and when, who signed off on this particular unit. All that data is being memorialized by the Proplanner system, and it's actually being made available for export to different BI tools, such as Tableau or Power BI, so that you can then take this data set and go run with it. Maybe you have some dashboards that you want to create or some customized reports. Proplanner is really not in the business of developing lots of customized reports. Now, we'll do it. We've got a selection that you can see here. But really, for the past 5 years or so, what we've realized is that people want access to this data, and they want to be able to create their own and configure their own on the fly. Right? They have specialists at their own company that can do this, or the engineers themselves. And so we're trying to empower them to do that. So to wrap up what we've gone through today, this Proplanner MES system is really designed for manufacturers of high mix, low volume, discrete products that need to collect lots of data, that have a strong link between their manufacturing process management system and their MES system, who need to collect lots of data on the floor and be confident that the right work was done at the right time. So with that, I'll go ahead and wrap up my portion of this, and I will go ahead and review if we have any questions that have come in during the session, and if not, we'll go ahead and wrap this up. Okay, so it looks like we don't have any questions that have come in during the session, so we'll go ahead and call it good. So thank you for attending today, and go ahead and shoot me a line at info@proplanner.com or hit us up through the website, and we can help to answer your questions. Thank you.